Okay, so the calculator I'm using is, I don't know how to say it. Facit. I've heard Facit or Facit. Facit is the manufacturer, and the model number is TK, Tango Kilo. Let me bring up. Okay, so the actual serial number is 216171. And based on the service guides that I've found, this actual unit was manufactured in 1951. You could then look at, based on when it was manufactured and what year, you would know what. Oh, my eyeball just broke. Oh, my whole thing just broke. That's not good. Yes, the math overloaded him. Um, his eyeball fell out again. I have to move my coffee out of the way. Hold on. The robot fell asleep. Okay. He's self-operating. Yes, this is like that episode of House. Okay. Will it work? There we go. Why is this head like all screwed up? So what am I actually doing is, I don't 100% know, but I think I do, which is a dangerous combination. So last year, so every year, Matt Parker does a Pi Day video for many, 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 many years. They've been doing Pi Day videos. Last year, they did a video where they tried to calculate 100 digits of pi by doing all the calculations by hand. And that's because back in like the 1800s, late 1800s, this guy William Shanks calculated pi to 530 digits, right? And then before he died, he published 2 more volumes where he continued his calculations, and they went up to 707 digits, I think. And that was the most digits of pi anybody had calculated up until like the 1940s. Because what happened in the 1940s is some other person using a desktop mechanical calculator, possibly like one of these, went and verified William Shanks's work. And it turns out in the first volume, so the first 530 digits that William Shanks published, there was an error introduced at 527. So, or the 528th digit. The calculation for that had an error. So he had only calculated 527 correct digits. And then his subsequent volumes published going up to 707 digits continued the work, which means that they were based off of an error, a calculation error. So he never actually got past 527 digits. He just didn't know it. So this method is apparently what he was using. And I don't know what it means, but 16 arctan times 1 over 5, or minus 4 arctan 1 over 239. And that equals pi. So what you do is basically you start with, and you'll see my terminology is the same that Matt Parker uses in his video. I'm kind of stealing his method, but really he's kind of stealing Billy Shank's method. And really, I think William Shanks used somebody else's, Machin's formula. So I don't know if you can patent or copyright or trademark math. Hopefully not. That would be ridiculous. But I think I followed along, and this is what I'm doing. So basically you start with 16 divided by 5. And then each subsequent value, each subsequent term in what he refers to as the spine, which when you go up here, you need to do a 16 divided by 5 calculation, or a spine for 16 arctan 1 over 5. And then you need to do one for 4 arctan 1 over 239. So there's these two main columns of calculation. So first you do 16 divided by 5, then 16 divided by 5, which is 3.2, you divide that by 25, and then you get another number. And then you divide that number by 25 again. So every time you go down this spine, you're dividing by 25, right? And then over here, you take those values and you divide by increasing odd numbers. So the first one's easy, is divide by 1, and you get 3.2. Then the next term you get is you take this number here, so it'll be hopefully 0.128. You divide that by 3, and then you get this value here, which goes into an irrational number. And then the next one down, you take whatever was over here. So the third number, 0.00512, we divide by 5, and then we get this number, right? And then you go down. And then once you've generated all the numbers you're going to generate, you go down here, and I've marked them. So you start with 3.2. Then you subtract this number. Then you add this number. Then you subtract this number. Then you add this number. Then you subtract this number, all the way down to however many numbers you're doing. So I'm hoping for 10. So that'll be, 3 I'm not going to really count. So we'll go like 6, 7, 8, 9, 10. So here, so you add and subtract alternating until you get your final term. The final term for this one will be this. And then you do it all over again for 4 over 239. Same process. 4 over 239. And then in this case, because you divide the results by the number squared. So previously it was divide by 25. Not too big a deal. Now it's divide by 57,121. It's a bit of a bigger deal. So then we go down here, build that out. Then we do the same thing. Go over here, take those terms, divide by these increasing odd numbers, and then alternate, subtract, and add them together to get our final term. And then once we have our final two terms, they go over here, and you'll see that there are equals is. So all of this is text. There's no actual formulas or math done by the spreadsheet. All I'm doing is, so you can see in this case, because this term and this term will be the same, I've just made it an equals, right? So this is equal to this. So whatever I put in here is just copied over automatically. That's all the automation in this whole sheet is just like a handful of copying automations. So this final term will actually copy automatically over here. So I have to generate this number down here, but I don't have to manually copy it over here, saving me from one potential copy input error and some tedium. And then what we'll have is a final number, which will hopefully be something like 3.141592. Is it like 653 or something like that? Which will be, pi. So that's what we're trying to do. We'll see how far we get. So on spine number 6. So then, okay, here's the other thing is I have what I'm calling my worksheets, right? So if you look at this, I have a starting value. And then that thing we talked about with how to keep track of decimal places on the machine. So this will be like the fifth term of, not 16 divided by 4, 16 divided by 5, the fifth term. And it's the first sequence. So if I have to carry over and do multiple little worksheets, we'll get to that in 4 divided by 239s for sure. Then I can keep track of the sequence numbers, right? So then I'd have like the same term, sequence 2, the same term, sequence 3, until I've completed it. So I have a starting value, which is coming from the spine. I figure out where because it only goes up to like 13 here and 8 here, I have to like keep track of how many spaces outside of this scale it's gone, right? So it's not really intended for this big a number, but you can do it, right? You just got to do a lot of number stacking. So it starts there. Then I actually manipulate the machine. I go through and I do the division, and wherever it stops, wherever it ends up, I'm copying those numbers down. So this will be the remainder. This is what I've been dividing by, and this is what the result is. And then when it comes into a multi-sequence thing, I have what I call the final result here. And this is what I'm actually going to copy over to the final chart or sheet. So that's what this is. So 16 divided by 5. We'll do term number 6. It'll be the first sequence. So now you'll see kind of what I'm doing if you can follow along. So we'll go over to term number 6. Derived from spine number 6. So the actual numbers, right? Because I don't want to put in all these zeros. I could, but they're just going to be chaff, right? So instead what I'm going to do is I'm going to enter them in as a shift of the decimal place, right? So we have 6 zeros. The actual digits are 3, 2, 7, 6, 8. So in my worksheet, I'll start with 3, 2, 7, 6, 8. Now, for my decimal setting, the highest it can go is position 13. But I have to add 1, 2, 3, 4, 5, 6 more, right? So 13 plus 6 is 19. If I'm using a single digit division, which let's check. So spine number 6 Six will be 11. So 11 will leave 4 zeros. And then my result will be 15. Right? And then you go with the difference between this number and this number to know how many zeros you're going to add in front. So we crank that out. So we go 3, 2, which probably means something a bit different. So we have that. And we're dividing by 11. Go down. Hold on. 3, 2, 7, 6, 8. I don't think I cleared counts. Oh no, I did. Okay. Right. So here's where this becomes important. So now I have 7. So 1, 2, 3, 4, 6, 7. So I have 1 here. I have 11 here, like this. And then 7, 8, 9, 0, 9, 0. Right? So in this case, I'm actually going to need the trailing 0, right? Right. So here's where I was at. So which is a 100 divided by 11, basically. Right. So, and I'm shifting down to the final digit, but I can't subtract anything. 10 minus 11 will underflow the machine. So I actually need this trailing 0. And so when I go into the next sequence here, I won't start with a 0, but I need to know that there's a trailing 0 because I have to add that in to how it's shifted. And that has to do with how you're going to concatenate these groups of numbers so that they're in the right position. When I was doing testing and practice, those zeros were all of my mistakes, basically. I had very few, after a little while, I had very few actual calculation errors. Everything else was in keeping track of where I was in the division, and I was missing zeros or adding them erroneously. So I think I've figured that out, hopefully. So we're still on term 6. This will be the second worksheet in the sequence. Okay, I made it. I'm back. Where were we? I didn't forget the timer. I did forget to run an ad until like later on. But yeah. Why isn't is the mouth moving? Why isn't the mouth moving? Oh, I think I gotta do, is it this? There we go. Send. There we go. Okay. Rose Crow, thank you for hanging out. Have a good night. Yeah, I'm not very mathy. Um I mean, I know math. I'm not I'm not one to come up with a formula. So um and I just thought it was fun because the Shanks method was um 60 years later or whatever, 40, 50, 60 years later, the Shanks method was shown, the results of his calculations were shown to have um, errors by someone using a desktop mechanical calculator. So I thought it would be kind of fun to do that. Yeah, okay. Oh, and I have done this quite a bit. Because this was like what I practiced on. So 4 divided by 239. Line 1, sequence 1. So start with 4. What are we? So 4, and that was 12. 239. So there's 3. So there'll be, sorry, 9. The result is 1, 6, 7, 6, 0, 1. And the keen-eyed will see that the remainder of 161 means that we are into a loop as well. So this is a rational division. So 1, 6, 7, 3, 6, 4, 0, 1. One. Oh, geez. So then we'll move on to the next one. Right away, overflows or underflows. There's also a way to do division in a shortcut when you have 9s. But I'm going to skip it for now because I'm not super confident. I don't want to screw up my calculation right in the middle of everything. Oh, you haven't looked into them as much as you should. Be careful. Because what'll end up happening is you'll buy a bunch. Oh, hold on. This is not good. So I've done a possible error here. Yeah. So if you look at what number I have here, 57,121. This is why I have these, instead of marking the decimals, because the decimals are run off the machine so high anyways, I'm using these as a placement. So the last digit of the number I'm dividing by can't run past the last digit of what I have in the accumulator up here, right? Because I actually have to add more digits down here. I just haven't. So because I've done this as my test so much, I actually know that the next two digits I think are 9 and 9, or at least that's what I remember them as. So I didn't really notice right away, but good thing I caught it. Because the subsequent digits will actually be important. So okay. So this is 4. So 2, 5, 4, 2, 5, 7, 1. Over here it's 0, 5, 1, 2, 9. 9. So 8 from 17 is 9. And then I think one more. Two. Oops. 2, 5, 4, 9, 2. And this is actually already run off the 10 digits. So I didn't even need to do this one technically. So then we can move right on to the terms. Okay. It's very confusing. And I'm not sure I understood it because you use the same groupings of numbers. The robot needs to be lubricated, not hydrated. You don't put water on robots, they get corrosion. So what we should do, okay, so to add them up. So I'm starting up here with the first term is actually just zeros. Right? Because it resolved at 1024. So then I'm subtracting 2, 5, 7, 1, 2, 8. So that's a subtraction. And it underflows. But then I clear that. 9, 1, 0, 2, 2, 2. And then I add that. Oh. I need another 2 in there. 9, 1, 0, 2, 2, 2, 2. So I add that. And then I need a 2, 9, 8, 9, 0. Let's subtract. 1, 0, 0, 2. is an add. And then a 3, 4, 9 is a subtract. And so you can see on the machine, there's no 1, right? So I'm working in a block of 7 numbers. There's no 99999, so it didn't underflow. So then I'm going to go down here, and my final term for this, I'm going to bubble in 3 or 7, 3, 6, 1, 4, 2, 6. And then I'm going to go back up. So there's no carryover. So I can see that's like -8 plus 9. So it should be like, yeah. Okay. So I think that's good. And then this block. So it's 3, 2. 1, 2, 3, 4, 5. And then 4, 2. Subtract that. Add that. And then 2, 9. Subtract that. Okay. So that's my final term there. So again, these are just equalses. Saves me from having to manually copy them over. So we go over here to the terms. So I'm doing this box here. So I want 1, 6, 7, 3, 6, 4. Be an add. 9, 7, 6, 6. Subtract. So now it's underflowed. So when I add this back, I got to remember to draw a -1 off the other calculation. So 0, 3. And I mean, I don't really need to do that, but okay. This is problematic. Because those are ones. Oh, no, wait. Hold on. No. Oh, this has gone horribly wrong. What have I done? So that's 4. So that's at 12. 239. So 3 zeros, so that's 9. So that's... Aha! Oh, that's just 16736. 16. So it'll be 16736. Okay. Is it okay? Oh. This looks a bit more familiar. I don't want to get my hopes up. But there's some numbers I recognize in here. Eight, 3, 8. Clear that. Okay. Oh, what? There's some more numbers I recognize. 1, 5, 9, 2. Okay. Okay. Now, I have a hidden row. Oh, no! How many did I get? Did I get 11? Yeah, we're reckoning. Frank, what's going on? Okay, ignore from over here. But look at that. My goal was 10. This right here. Oh, hold on. I got a thing. Hold on. 1 second. Oh no, my eyeball broke again. Check it out. I got a piece of pie. It's a blueberry pie. I think I've earned a slice.